In the early days of engineering, everything began with a pencil, a ruler, and a vision. Blueprints were the language of progress, static, precise, and beautifully simple. But the world changed. Today, those blue lines have transformed into neural networks, dynamic, self-learning systems that design, predict, and optimize beyond human reach. What was once an architect's sketch is now a living algorithm capable of evolving every second. This is the AI shift in environmental engineering. Until recently, environmental systems were modeled manually. Think soil permeability, fluid dynamics, or contamination spread. Engineers would spend months simulating flows and pressures using fixed formulas. But AI does in minutes what used to take months. Neural networks can now learn the hidden physics behind groundwater flow, pipe leakage, sediment transport, and evaporation patterns. Instead of assuming, they infer. Instead of approximating, they adapt. In a pilot project by the European Hydrology Initiative, an AI model trained on 60 years of rainfall data predicted aquifer response with an incredible 97% accuracy, outperforming every classical model that had been built by hand. The shift is irreversible. The blueprint era is ending, and the era of the intelligent model has begun. Modern engineering AI systems don't just compute, they observe. They absorb satellite imagery, drone footage, soil humidity sensor data, and thermal readings to continuously adjust their understanding of the environment. In one experiment at the University of Delft, engineers fed satellite radar data into a generative model. This AI could redraw river floodplains daily, responding to every single millimeter of rainfall. It was as if the machine had learned the river's personality, its bends, its memories, its moods, and it began designing levees that looked organic, almost as if nature itself had drawn them. This isn't just artificial intelligence anymore, it's adaptive intelligence. So today's environmental engineer doesn't just draw, they code ecosystems. They train convolutional networks to optimize drainage, use generative algorithms to design water grids, and deploy reinforcement learning agents that balance cost with sustainability. Imagine a neural network that designs an entire wastewater plant, adjusting every valve and tank size for maximum efficiency, all while minimizing energy use. Well, that system already exists. AI tools like deep reinforcement control are now being used in Denmark's urban water systems, saving over 25% of pumping energy while preventing overflows during storms. Blueprints were static. AI systems are alive. The next revolution is generative design engineering. This is where an AI generates hundreds of possible infrastructure solutions, evaluates each one for environmental impact, material cost, and carbon footprint, and then chooses the most sustainable option. In a single iteration, an AI might produce 400 different bridge designs. Each one is slightly different, lighter, stronger, cheaper, greener. Engineers no longer have to decide what works best. They curate what the algorithm proposes, and every iteration makes the AI smarter, learning not only what works, but why it works. This creates a powerful feedback loop between design and discovery, accelerating sustainable innovation faster than any human team could ever manage. But the real power of AI isn't just on the screen, it's in the field. AI-driven drones now scan soil, moisture, and identify contamination hotspots. Deep learning models can detect microfractures in dam walls through thermal imaging long before they could cause a failure. Predictive algorithms balance urban water supply against agricultural demand in Ribu Band, preventing shortages days before they happen. In Hyderabad, India, a municipal AI platform reduced water leakage losses from 38% down to 14% in just 1 year, simply by learning where pipes were most likely to fail next. Every data point, every single drop, becomes part of a system that is continuously learning. Yet, no matter how advanced it becomes, AI doesn't replace the human mind, it extends it. Behind every algorithm lies a question, a boundary condition, a moral choice. How much autonomy should we give machines that control our dams or predict floods? Who is responsible if the data is biased or the forecast is wrong? The engineers of tomorrow will not just manage systems, they will govern intelligence. And as AI designs, builds, and maintains our physical world, we must design the ethical frameworks that keep it aligned with human and environmental values. We no longer build with stone and steel alone. We build with data, with insight, and with a promise that intelligence, when guided by conscience, can heal the planet it once harmed. Thank you so much for watching. If you found this journey into the future of engineering as fascinating as we do, please hit that like button, subscribe to the channel, and share your thoughts in the comments below. We'll see you in the next one.